Hey there and welcome back. This is lesson 5.5. Skill 5.5 says this: I can use the molar mass to calculate the percent composition of a compound. So what we'll go ahead and do is talk about what is percent composition to begin with, and then what I'll do is show a couple problems, okay, of potential problems you might see in your classroom. Let's go ahead, let's get started. So let's go ahead and key in on the keyword of this skill. And the keyword is percent composition. So when I hear this word, and what you should also think of is a pie chart. This is how I visualize this. A pie chart as a whole, okay, is equal to 100%. And it is divided into specific groups that represent specific items, okay? And what's cool is when you add up these percents, okay, so if I put 15% plus 25% plus 28% plus 32%. Again, what this gives me is 100%, okay? So these groups can represent compounds, and for this example, what we will do is we will take water. We can take the formula for water and break it down into molar masses. So every hydrogen weighs approximately 1 gram, and there's 2 of them. So if we multiply 2 by 1, what that gives us is roughly 2 grams. Every oxygen weighs about 16 grams, and there's only 1 of them. So this oxygen weighs 16 grams. What I can do is I can add both of these numbers together, okay? 2 plus 16, and get a total of 18 and draw a pie chart. So this is telling me is that this entire pie chart, instead of 100%, is equal to 18 grams. And in accordance to what I see here in terms of individual masses, I can go ahead and divvy up this pie chart. So I know that 2 grams out of 18 is roughly 10%. So what we can say is that this is roughly 10% hydrogen. And then the rest of this pie chart, 16, is about 90% oxygen. If you find the total molar mass, okay, so if I find the total molar mass of any compound, what I can do is find percent compositions of individual elements that are listed in the compound formula. And again, the same way that you could write a pie chart for a multitude of things, I can make a pie chart in my head for the masses that are part of a compound, and that's basically all percent composition is truly about. With this type of pie chart concept in mind, now let's scroll down and see what a sample problem would look like. Okay, so here's what a sample problem would read. Find the percentage composition of a compound that contains 17.6 grams of iron and 10.3 grams of sulfur. The total mass of the compound is 27.9. So here's what they're telling us is that we're going to have a pie chart that kind of looks like this. Okay? The total mass of this pie chart, or the total mass of this pie chart represents, rather, will be 27.9 grams. And that this will roughly be about half and half, where we'll have 10.3 grams of one substance, and then a larger half of 17.6 grams of the other substance. But they don't want masses, they want us to convert this to percentages. So how do you convert a mass to a percentage? Here's a really simple formula. All right, so the definition of percent comp has magically appeared here on the upper right-hand portion of your screen. And what you want to do is make sure that you write this down into your notes, because this is the formula that will guide you through any kind of percent composition problem. So anytime we take the part we divide it by the whole, and we multiply by 100, okay, that will give us the percent composition. And what we want to do is look for these items here now in the problem, okay? So they say that the total mass of this compound is 27.9. So this is our whole. That will always be our denominator. And what I'm going to do now is find the parts. So we have, here's one part, 17.6 grams of iron. And then here's a second part, 10.3 grams of sulfur. And what we will have to do is perform two separate calculations. And we're going to run two horizontal lines of calculations for both. And hopefully we come up with a pie chart at the end, okay? So here we go. So iron's total is 17.6 grams. That's the part. Divided by the total of 27.9 for the compound. And now you need to take your calculator and punch all this in. Turn this fraction into a decimal. And what you get is this 0.63. And remember, the last step is this, multiply by 100. Take the fraction, multiply by 100. What that gives us is 63% iron. All right, here's the next bit. Let's calculate sulfur. So the part is 10.3 grams. Divide that by 27.9 grams. Again, turn that fraction into a decimal. That turns into 0.37, okay? Multiply that by 100. And that will give you 37% by mass of sulfur. The last thing now that you should always consider is, do my percentages add up to 100? That is kind of like a self-check tip to know if you got your answers correct. So what you want to do is this. Create a pie chart, okay, as a visual, and then see if these numbers add up to 100, and then create the pie chart if they do, okay? So 63 plus 37, if you punch that into your calculator, what you do get is 100%, okay? So perfect, our answers are correct. We've just checked them. And now what you can do is pretty much just kind of draw a pie chart if you'd like a visual aid here at the end. So we'll have 63% of iron in this compound, and then we'll have 37% roughly of sulfur in the compound, and that would pretty much be your final answer. Depending on how you rounded your answers, your percentage could be off by 1% or 2, and I would say that would be still correct. But if you're ever off by a multiple percent, or your numbers do not add up to 100, then that's a first indicator that you've done something incorrect, and it's time to go back and check your work. The problem that we just completed is a simpler example of a percent composition problem that you will see in a chemistry class. So the reason why this one was simple was because they provided us the masses. So in this next example, what you will notice is that masses are not provided, and we will have to scavenge for those ourselves. Okay, so here's what it reads. What is the percent by mass of oxygen in magnesium nitrate? Okay, so we have this formula in the back of our heads, part by whole, okay, but we're wondering, where do we get these masses? And something that is always available to us and that you can do with any kind of formula like this is calculate a molar mass. So when you're asked to find percent by mass, but masses are not included, what I have to think about is this trusty old thing, my good old periodic table. So what we will do is calculate the molar mass of the entire compound first, That will give us the whole of our formula. And then what we will do is we'll take the part, which happens to be oxygen in this case, find the ratio, and then multiply that by 100. Let's go ahead and list our elements so we can calculate their masses. So I see magnesium, I see nitrogen here, and I see oxygen. So what I need of each of these now is their molar masses. So let's go find them. All right, magnesium is 24.305. Okay, nitrogen, let's figure that out. 14.007. And now oxygen, let's find that one out. Here it is. 15.999. To continue with the molar mass calculation, what we now have to do is multiply these individual masses by the quantity of that element that is in the compound. All right, so magnesium, there's only one. So that will give us still 24.305 grams. How about this? How many nitrogens do we have? Well, nitrogen doesn't have a subscript right next to it, so that signifies 1. But notice that there are 2 of these nitrate groups. So what that means is that I have to multiply 2 by 1. We have to multiply the nitrogens by 2. Let's go ahead and do that. That equates to 28.014 grams. All right, last but not least, let's figure out how many oxygens there are. So oxygen has a subscript of 3, but again, with 2 nitrate groups, I have to multiply the 2 by the 3. That means that there are really 6 oxygens present. So let's go ahead, let's multiply 6 by 15.999. And what that gives us is 95.994. So last step is I want to take all of these masses and add them together to come up with the total. So let's go ahead and do that. And here's my total. 148.313 grams. So this is my whole part of the fraction, okay? And what we can do now is actually compute the percent mass of oxygen by using this formula, okay? So again, this is the whole. And then the part will be the molar mass of oxygen from this compound, okay? And all you have to do is stick this into a fraction and then multiply by 100. So let's go ahead and do that. So 95.994 divided by 148.313. Let's see what that gives us. Gives us a decimal of 0.65. Remember, you have to multiply by 100. So what that ends up equaling is roughly 65% oxygen. And that's your final answer.